Hey, I'm Gavin with Abley, our digital engineering team here, and we're going to talk about some of the obscure uses of FME that we've done in the past, another FME Fireside. I'm Gavin, this is Todd, this is Hamish. So, gentlemen, what are some of the most fun/obscure uses of FME that you've done over the years?
I'd add another one to that and say also non-sort of standard use.
Yeah.
Because you often see FME targeted to GIS and spatial, but really it's a lot wider than that. And I've used a lot of what I do now is probably non-spatial FME stuff. And spatial is just a secondary aspect, and really data is data, and FME just handles data like anything else.
Yeah.
Well, I'm going to rock out there and say 10 years ago is probably when I started using FME to write FME. And what I'm getting at there is basically writing it back in the old FME kind of script using functions and factories, which is a whole nother conversation. But the ability for it to actually write its own configurations, so you could actually then run stuff.
That's crazy, because one of the ones that I'd forgotten about until now was back when I just was playing around with it and learning things and whatnot. I created some Auto-HotKey scripts. So then I would write out Auto-HotKey scripts that would run off of command line and batch files and that type of stuff. Just on my desktop at home, doing really cool things with the home license.
Yep.
Well, what I thought was cool. I'm sure I don't know what it did any longer. It probably broke a lot of stuff. But.
So for us younger folk here, so you wrote basically FME in a text file.
Correct. Yep.
Down to .fml or FMW files.
Not FME files.
Oh.
So .fme. And basically, it is you write out your writers, your readers, all that sort of stuff. Know the syntax of the factories and functions that go in behind.
Yeah.
Very powerful. You can do lots of things with it.
Okay.
But actually, these days you would just jump into Workbench and you'd be happy with that. But I had a situation where, and again, it'd be easier to do now with some of the things that are involved, but I had a spreadsheet with like 10,000 records that I needed to put values in, and it was much easier to use FME to actually write that out than it is to do other things. And, in past as well, I've written other scripts using FME because, you've got that logic.
Yep.
I mean, JSON's a great example, and XML of things that you can template up in FME and be able to produce stuff. But, it works on any of those things.
Yeah, and I still have old dog syndrome, and I still write out text as a writer, but I'm writing HTML files. And because that's just how I learned how to do it.
And a lot of files, programming files, are literally just text files with a different extension. I've done the same with JavaScript. Back when I was involved with Nectar after the Christchurch or the Kaikoura earthquakes, we had a web viewer that we'd update periodically with new features built in Esri's Web Builder. And I built an FME process that would take our development environment, read through and parse some of the JSON and JavaScript that comprised of that whole application, make the required changes, and then automatically push it up through FTP to our web server. And it was just, a simple click of the button, and it compiled it all and built it together. And I'm sure there were better ways to build and compile JavaScript files, but I used what I knew, which was FME.
I want to talk too. All right, quickly, because we're probably going to have to talk about dynamic workspaces another time. But I love how you can create dynamic, just like web pages or what have you, where you can write out brand new CSS, JS, and HTML files based on your input. So you can create web maps that are just new data comes in. FME server, and you've never seen this file before, but as long as you account for it being potentially a new file set, then you can write out that on your, let's use a web map, for example, web page of different sorts, but you can write it out dynamically based on just the same concepts you were just talking about.
Yeah, shouldn't get structured and tagged.
Right. As long as
logical.
whoever the user is formats things properly.
Yeah, and where I was going was a similar rebuild situation. So Skirt, which was rebuilding Christchurch after the earthquakes 10 years ago. Again, webmap where we had 15 different roles, 15 different configurations. And of course, you didn't want to, if one of those things changed on one of them, you wanted them to apply to all the others. So, we just had configurations that were just like one word saying bus routes. And then it would, you'd have something in the background that configured the bus routes. And whenever that changed, you just hit a button and it went straight throughout all the different configurations and worked like a charm.
Yeah, that's awesome. The non-spatial element of FME. So we're talking about writing out web maps and web applications and that type of stuff. One of the ones that I've enjoyed doing over the last year or so is writing out, coincidentally, I guess it is, to HTML, but it's a cross-sectional drawing using HTML5. So more or less making diagrams using HTML and then converting that to PDF for a PDF write-out. That's one of them.
These are your pothole ones.
Yeah. So it does cross-section where you can see all the subsurface information just onto a PDF, drawn on a PDF, diagram-wise. That's been a really fun one. A lot of learning because you have to configure like the distance from the edge of the pothole and how that relates to pixels and all kinds of stuff there. So it's been a fun one for sure. And just learning some of the HTML5, like Bezier curves and those types of things within that.
And that's been a fully FME-centric process?
The whole thing is FME.
Yeah.
It just reads in CSV files and then draws out the cross-section of that. It's hard to describe just in verbiage.
Yeah.
But yeah, it's been a fun one just drawing those up based on tabular data.
I've got one, and you'll remember this. Building a Cypher / salting a password. Well, not password. It's not password. It's just encrypting.
So describe what a Cypher is.
So basically, we've got a ID that we wanted to hide from the users because it would lead. If you knew the ID, you'd be able to figure out some other stuff. So we need a way
to be able to figure out relationships.
Yes. Yeah. And so what we needed to do was change that number up that it could be encoded and then unencoded during different processes. And basically, initially I looked at doing it feature by feature, but we were talking millions and millions and millions of features. Heading towards the billions. And so that was going to be an awfully slow process. So jump into what can do it really, really quickly, and that's point clouds and FME. And this was non-spatial data, it's just tabular data, but it doesn't. Point clouds in FME don't need to be points. They can be just empty geometries.
We should do a Fireside on that sometime.
Yes. Right, cool. And basically doing the calculations to break it up into the certain things that I needed it to be to make up this encoding was a bit hard. It's only mathematics I can use, so had to break out the mathematics brain that day.
So a point cloud can't contain.
Oh, you can't do
alpha characters.
Do calculate. Oh, it can,
yeah.
but you can't do kind of calculations or expressions utilising those to a great extent. You can do certain bits. So building that process, and I was like, sweet. So I've got it encoded, and I was like, yes, And then I went, oh, now I need to decode it, and using the same logic I'd used on feature by feature couldn't be done on in the point cloud, so I had to build a mathematical way of doing the unencoding, but it worked and it's super quick. So as soon as we get into that point cloud data set, bang, I've done everything, and then out the other side, break it up into the points again.
Yeah, that was pretty sweet.
1.3 seconds to do 40 million or 50 million?
Something.
50 million
I think
features?
for 40 or 50 million was like pushing 15 seconds. I think it was like 8
No,
million.
that was a reading though.
We're all about the
Yeah,
numbers
okay,
here.
we're all about numbers. It's super quick.
Semantics.
It's super quick. It's super quick. So point clouds, I've got to say, grown a bit of a love affair with those over the last couple of years.
Have you ever?
Yeah, and I mean, jump to another process. We did Safe View, or what we call Safe View, which is basically how far a car can see in front of it at any point down a road. So whether it can see an oncoming car that's 300-400 metres down the road. And where also its vision stops. And that's again all point clouds based on where basically points along the road to see and of course out into the vicinity of the road to see how far you can actually see. And a single point
that was used to work out overtaking.
Yes.
Yeah.
But so a single point looking 330 metres down the road each way, I think ended up with 64,000 calculations, and we could calculate 30 kilometres or about 18 miles from memory in 20 minutes, and that was 1.8 billion calculations, and then it would just spit out a few things at the end. It's super cool because when you usually did that type of thing, it would be from a couple of fixed positions, but being able to do it down a 30 kilometre 18 mile stretch of road in a matter of minutes is really fun.
And a really novel approach of using point clouds.
Yes,
because point clouds typically
you don't think about making them yourself.
And you typically get elevation data. A point cloud is more typically used for sort of survey level stuff, but then applying it to a non-spatial piece of data is something quite impressive and quite different.
Yeah, so kind of tying things all up in a bow here. Do you have anything that you're doing now that you consider like, I don't know, innovative or fun or...
Well, something... So we've got a piece of software, and this is going back to point clouds. We've got a license for a piece of software here that is a really powerful LiDAR processing tool that can extract, classify unclassified point clouds into ground and begin to pull out some features out of there. And it's a standalone, typically command line driven tool. And we found real benefit of being able to package up these tools, which are... There's probably about 30 or 40 tools within this piece of software, very much like FME with your transformers, where you need to chain things together. So what we've done is compile all these tools into individual discrete custom transformers that you can then link together to process your LiDAR and output DEMs, TINs, classified point clouds, RGB imagery, with the main purpose of then feeding that into CAD pieces of software for designers and whatnot to work with. So that's been a pretty cool project, and it's very much a work in progress. It's something that is evolving each time we're using it, and we realise, hey, can we do this?
Yeah, cool.
So that's a cool one.
I can't think at the moment.
Yeah.
But I think probably from week to week we do cool, fun stuff with FME, and that's actually what I really enjoy about the job. Yeah. Especially I think it's just those new things like, could it do this? And the answer is often yes.
Well, a great example, the new HTTP caller in FME 2021. There's a new concurrency ability so that you can make concurrent calls, and we had a bit of fun playing around with that, but it also highlighted a few issues with it and ways that you can abuse it and ways that it might actually change how you currently work. And that was we spent half an hour looking at that.
Yeah.
And that was something that was really interesting to find out.
Yeah. Cool. Well, I think that'll kind of bring it all together. Once again, we're Abley, the digital engineering team, and Hamish, Todd, myself, Gavin. We will be back at you again with another Fireside in the future.